Alright, here we are working on a HR2510 that somebody wanted to part out, so it had some key components missing, but I didn't give up on it. So here is where we are. Here's a schematic for it, and here is the final, and here's the driver before the final. And what I found was a short circuit on the board between the collector, the third pin, and ground. Well, it sure looked like the final was blown. So I lifted the pin off the board, and the transistor itself was fine. From the collector to each one of these, it was very high impedance, 1,000,000 ohms or something. So the only way this pin, this trace could be grounded is through these caps right here. And no, that wasn't the answer, because there they are. That wasn't it. So you have to continue tracing. I mean, I'm shortening this up a lot. This took me hours. So if it's not going this way to these three caps shorting to ground, then it's got to go through the inductor. See, it goes here, here. These coils are only, they're close to 0 ohms. The only way it could get to ground again here or to any of these is if all these caps shorted, or just this one. If this one shorted, it would go right here to ground. You see that cap? Do you see what's not right with it? It was up against the big inductor, and it had that glue that people don't like, and it nuked it. The thing's all brown and blown up and all that stuff. So I ripped one out of one that we are parting out. Okay, see the two big inductors? Yeah, that's not, I can't show you that way. Okay, alright. Two big inductors. See the green cap right there? That's the one out of the one parts radio. It's in good shape. So as soon as I pulled that cap out, the bad one, and checked everything with an ohm meter, the circuit opened up. So it was basically taking the final and shorting its output to ground. And that's not okay, as you might know. So anyway, it took a while to get it. I'm making this a short video because I'm tired, but this is what happens. You don't assume anything. So the final was not blown. It was the stupid capacitor. It looks like it got overheated, and yeah. So I got to put those other three caps back in. And I haven't seen a ceramic cap blow up in, I don't even know, decades. But there it sits. So I'm going to put all this back, and then we'll check the output, and we'll see what we got. Back shortly. Alright, to finish off this 2510, here's where we went. This transistor changes the state of both of these, so receive shuts off and transmit starts, and then when you let off the mic, receive works and transmit stops. So I checked these three, they're all working. The output to here is working, to here is working, but from here to here there's a problem. Now what gave me a clue of what to look for is, if you look at 124, let's see, 124 is right here. It says it should be around 8 volts in transmit mode. The collector should be about 8 volts, okay? So I'm looking at 124 and I'm getting 8 volts. So I'm happy about that. But I know the finals don't run on 8 volts. I just don't know what they did run on. So you look here at 132 and 133, and they run somewhere around 13 volts on the collector pin. Okay, in either state, transmit or receive, both of them. So 13 volts, huh? So I'm looking at these two, and I put my voltmeter on them, and when I key the mic, I get no voltage there. And they're also not shorted because I tested them with an ohm meter first. So where does it get its 12 volts? Well, it turns out it gets its 12 volts from this board here on the top, right here. 12 volts gets right here to here, and way over here to right there, tied right next to the big filter cap. So the 12 volts goes from here through the board to here. So I check right here, I got no 12 volts. Ha! I got no 12 volts to this point, and it's a single trace all the way through, right on the schematic. So then, not knowing where this was all supposed to go, this is the top view of the board, the component side of the board. God, I hope I can find this, because it was freaking cool finding it and troubleshooting. Okay, so here's the huge filter cap, and let's see, where does this go? You'll see a trace here, you see a diode, and a trace here. The 12 volt, well, 13.8 goes here. There's a big jumper. And then there's a trace across here, and another big jumper, and another jumper, and a trace that follows it over to test point 4. So I just started using my ohm meter from here to here, and it was open. And to here, it was open, and then across to here it was closed. Really? What's here? A little trace. Okay. So let's see, can I show you that? You've seen this before, almost everybody has on these 2510s. You'll see a burnt trace here and a burnt trace here, and then somebody jumpers them. Well, that was, 2/3 of the problem. The other was the other jumper right here. What I did, God, I don't know if I can show you this one-handed. If you take and light up the board from the bottom, that's what I did over on that in that area, and I could see a clear break in the trace using this flashlight under the circuit board. Worked like a charm. I saw a guy do it in a video recently, and I thought, okay, I'll use that someday. Well, tonight was that day. And so that trace was wide open, and it was melted. So I jumpered a piece of the leg off of a 1 watt resistor. I used a great big one, and then I filled it with solder. So that won't burn again if anything else does burn again. So then I checked with an ohm meter. I checked. Here's the huge filter cap. I checked from here to here, obviously, and then the power made it to here, which means it makes it to these big pads here are for the test point 2, 3, and 4. So that's what was stopping the 12 volts from getting to these two, the two finals. So now what we have, breaker, yeah. Now we have something. So I am thrilled. I don't have a good light in the front yet. It's half attached. It was attached to 8 volts. It was always real dim, and I didn't know why. So I need to find out where it's supposed to go and hook it back up. But the display does work. Let's see if we can. There. That's the receive mode. Seeing a nice signal from the 1200S. Anyway, so this one was tons of fun. There was a lot wrong with it. And now it works fine. This goes in the to be tuned pile, and it works. It had previous flaws from somebody not finding it. So anyway, I'm happy. I got it. It took forever because there was a lot wrong with this thing, but I had to just go through the schematic. You start back with these transistors that the power, the receive, and the transmit, depending on the state of the microphone, and you just start following it through. I skipped all this because it's kind of hard to get to. I just came here and I said, if I got it here, then all this is fine. I was right. I got it here, and then it stopped. So the 12 volts, see, this is run on 8 volts. That was a huge clue, because I knew these couldn't be run on 8 volts. That's not enough power. So anyway, that was it. That was the big clue the schematic gave me. So anyway, I'm thrilled. These old schematics really helped on this one because there was a lot wrong with it. And now there's nothing wrong with it as far as I know. And yeah. Okay, so that's the end of this radio. This is radio number, see that? Number 4. I have 1, 2, 3, and 4. As I work on them, I think this was the, I don't remember. I think there might be one of the first 3 that needs a little work, but 1 is good, 2 is good, and I'll check number 3 after this. But 4 was a pain in the butt. It was just massive. And now it's good. Alright, so that's it for the 2510 for this video. There'll be more later when I get to them. See you, bye.